Unleash the power of your data and drive innovation forward with uniquely simple, integrated solutions from Pure Storage that deliver a modern data experience.
Hello everybody and welcome to this presentation. My name is Magnus. I am a database consultant with my own company, Transmocopter SQL AB. And I am tired of the pandemic. I know you are as well. Despite that, I'm really happy to be able to present on this conference, and I'm really happy for all the people who put in all the hard work to make this happen and make it as fantastic as it is. But I want to meet people. I want to be in an auditorium or a classroom and have eye contact with you. But here we are. Stay safe. Keep the distance. We will get through this together. What I'm not tired about is software quality. So I've been working in the IT industry as a software developer, as an architect, as a project manager, but all the time with a strong focus on the database backend or database platform. And I love software quality. Or rather, I hate fixing bugs late in the development process. And that's what test-driven development is all about. And today I will talk about test-driven database development. But let's start with defining test-driven development, okay? So what is test-driven development? You have probably all done development or been involved in development project of some kind because you are on an IT conference. Test-driven development starts with getting requirements. And that's no different to any other kind of methodology. You get the requirements. And if you have been involved in development yourself, you know that requirements can be good or they can be bad. But even with good requirements, you as a developer will take some decisions. So you get some requirements about, let's say you're going to write a currency conversion function. So this function will require calling an external service to get the rates, okay? And you start writing your code, and then you get the rate, and you look at the API for the external service, and you see that there are more than one rates. You have the end of day rate, you have the average rate, and which one do you want? Do you want a specific point in time during a day? What if that's not even a bank day, so you don't have a currency rate that is actual for that time? Will you then take the just latest available, or will you take the average of the latest, I don't know, the latest open bank day? These are decisions that you as a developer will take. Some of them you will ask for more requirements or better requirements for, but some decisions you will take. And they will be so-called undocumented design decisions. With test-driven development, once you get the requirements, you don't start writing code, you write tests for the code that you will later write. And this means that the assumptions you make, You will write tests for them. You will name your tests in a very sane and understandable way. And then some of your undocumented design decisions will now be documented design decisions, because there will be test cases for them. And the test cases, that is your documentation of your function that you're writing, your unit of work. When you have written the tests, you run your tests. And since you haven't written any code, chances are your test will fail. But in some cases, they won't, because you get a new set of requirement for an existing module. And you write the unit test only to see that, okay, I already took a decision when I developed this module to include this requirement, because I thought that would be the same thing to do. So then your test won't fail. It will be successful. That means you can go have lunch, come back 2 hours later and tell your manager, I'm done. And the manager will say, that was quick. And you say, yeah, I even tested it. So not often, but sometimes that will happen. If the test fails, you will write code to fix the failed test. Then you will run the tests again. And hopefully you didn't break anything. And this is also a key thing with test-driven development. If you have used this methodology from day one in the life cycle of your application, you will have unit tests for everything. You will have a really good test coverage, which means if you go into the most complex function of the system and you write some code, you change something, and your requirement now works, but something else breaks, you will know that now, and it's up to you to fix it, of course. But you'd much rather want to fix it now than finding this out in an integration test. And you first have to start digging into logs and see, where is it my module? Is it the integration between two systems? Is it the presentation layer? If the unit tests fail for a module, that module has something wrong with it. Or at least it doesn't fulfill the requirements as described by the tests. So in essence, this is test-driven development. Let's look at an example. So the example I'm going to show you, it's a very, 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 very simple software. It's not even a project. It's a hack that I threw together. It's a console application. It has one function. The function's name is isValidDate. So it's for date validation. You send a string to the function, you will get back true or false. And the requirements are very, very rudimentary, but they're good enough to be able to write a test case for it. So let's have a look. As you can see, I was not lying. This is a tiny, tiny, tiny program. I have my main function. It has one console.write line saying nothing. We're not even going to run the main. We're just going to look at this little function. One thing I've done now is I've made this function public and static. And it's so that I don't need to instantiate it when I run my test, because it should be a static function. And since my test is a project outside of this one, I needed to make it public. For any C# developer, there are probably better ways to do this, but it works as an example. So anyway, I have this function isValidDate. It takes the input inDate, which is a string. It creates a regex, regular expression, and this one is my requirements. So the requirements are a date should have 4 numbers, a dash, 2 numbers, a dash, and 2 more numbers. So the date format I have in my comment here, that's the valid date format for you. Then we do a match. So we take this regular expression object, we make a match with the input in date. And then we return the success property of the match object. Very simple. And here are the tests. And I told you you should start with tests, and I did, but I showed you the other way around. We're going to start with tests when we make some changes to this. I have two test methods. One, which I describe as European date format is okay. And the other one I describe as American date format is not okay. So this means a date on this format, month, day, year, is not okay. But the year, month, and day format is okay. So in my test methods, I make an assertion. I assert with the isTrue method that something is true. And what I check to be true is that my function is validate with the input 2021-08-30 is okay or is true. And then I make a negative test, assert that something is false. And I assert that isValidate with an American date format returns false. Very simple. So I have built my solution. I can now go to Test Explorer and do run all tests in view. So I click this, it runs through the tests. Since my project is so small, it just takes milliseconds. If you have a really big project, there is going to be a build phase and some of the tests may take longer to set up, but in this case it's super fast. Let's zoom into Test Explorer. It has the structure of my project, or actually my solution, no, my project, and then my class, program tests, and then my two test cases. American date format is not okay, European date format is okay. And if we go back to look at the code, you see the decoration test method here, and a very descriptive string to describe the test. Then I try to be as descriptive as I can in the name of the actual function, but what you will see in Text Explorer and in test reports will be this string. So be descriptive. When we later move to database tests, the same thing goes, of course. So this is just to show you the methodology, and this is common knowledge to most C# developers. They will know unit tests by heart. Let's make a little change to the documentation or requirements. I get the requirements that American date format should be okay. So this test case, I have to scrap it, but I'm not going to scrap it. I'm just going to change it. So I'm going to change it to American date format is okay. I'm going to change the name of the function to isValidate test positive American date format. And then I'm going to assert that the American date format is okay by using isTrue. So now I only wrote my unit tests. I haven't changed the code. So I would guess the test will fail, but let's test it. Let's run the test suite. Now it's building and it's all red. So we see we have red on top, and the reason is one test case is red. That means the whole test suite failed. And assert.isTrue failed in the American date format is okay test. So let's go into the code and fix it. New requirement, American date format also valid. So I have another regular expression with another string format. I make another match, and I return not only if the first match is okay, but with an OR clause, I check with the American success rate as well. Let's rebuild the solution and rerun the test suite. Rebuild, all succeeded, run the tests, and now it's all green. So for a very simplistic function, this may seem like overkill. It does to me when I started with it. But if you get into the habit of writing your unit tests, then write your code to fix the failed tests, your quality of code will be much better. You will not have to chase errors in integration test periods. You will find at least the errors in your own code immediately. So let's go back to the presentation. Test-driven database development. Why do we need it? Well, one key thing about unit tests is to only test your code, right? So if you have external dependencies in your code, what you would typically do is to create mock objects for the external dependencies. Let's say we write the code for the currency conversion that looks up rates in an external service. Typically in the unit tests for the module to do the conversion, you will create a mock service that, given a certain input, will always return the same output. Or even more simplistic, given any input, it will always produce the same output. It depends on what you need from your own tests. So what else could be an external dependency? Well, for most C# developers, or all, the database that you are responsible for, that's an external dependency. Even if the backend developer writes their own SQL code in the database, it is still an external dependency because it has to have some certain test data. The schema has to be okay, which means the deployment of the database pipeline has to have worked. And you don't want to be bothered with that when you're going to test your code in the backend. But this leads to a situation where you can have really good test coverage in the backend code. But when it comes to the database, it's mostly untested, and you don't want to ship a product with untested code in the database. So of course you do your system tests and integration tests, and you let your business users click around in the interface, and you have some beta testers if it's a public software. But if you come further down the development process, you're getting closer to delivery, and then you find errors in the database code, which you fix. And how do you know it all works together? Well, you have to rerun the integration tests, and it's going to delay your development process. So that's why we want to introduce unit tests in our database, and even start to develop using a test-driven methodology in the database code as well. So how do we do it then? How to do it? Well, same basics as the backend code. Test one unit of work, mock dependencies, and so on. Don't rely on other services objects. Don't rely on data. So that's the first thing. One of the tool sets you need is an empty database, or at least you need a tool set that allows you to work as if objects were empty in the database. Because if you rely on a database to be deployed with a certain set of test data, well, then what you are actually testing is the populate scripts for the test data. That's not part of your business logic in your stored procedure or function or just dynamic SQL code that you're writing up, right? So create the test data inside your test, remove the test data once the test is completed. And you will want to have a tool or a tool set that will help you to do that. And I'm going to talk about two of the tools today. T-SQL-T, which is an in-database tool. You deploy it to the database. The tests are defined inside the database. And I'm also going to show you a bit about the Visual Studio test projects for database projects. And they work a little bit differently with how you prepare your test data. I would say maybe T-SQL-T is a little better at mocking dependencies when it comes to data. But you'll see, and it will be a matter of your taste and your team's taste, what you like, what works best for you. So T-SQL-T and SSDT and Visual Studio test projects. So I'm going to start with a demo of T-SQL-T. It will not be very in-depth. It will show you what T-SQL-T is, what you need in the database to run T-SQL-T, and I will create the first T-SQL-T test and then show you how you can mock data with a fake table stored procedure, which comes with T-SQL-T. Actually, before I do any Management Studio demo of T-SQL-T, I just want to show you one little thing. And it's how I usually handle my test infrastructure when I'm running tests locally. Because you have probably done this same route I've done. You install SQL Server locally, and you install, let's say, SQL Server 2016. And then the pre-release of SQL Server 2017 came out, and you want to install that, so you create another instance. And then the final version comes out, so you update or you upgrade your instance. And then the pre-release of SQL Server 2019 comes out, and then CTP2 comes out as well, so you have two instances for that. And your system is far from what the workstation that you want to work on. So you can come around that by using containers, which is very suitable for testing as well. Because a container is very lightweight, you can spin it up quickly. You can have a container containing SQL Server, you spin it up, you run your test cases, and then you kill the container and it's all gone. You don't have to think about it. So the code you see on screen, that's all you need basically to spin up a container. So what I've done here is I create a volume. You don't even need that because for a unit test container, you just want to run the tests on it. The data, you don't care about it because you run your tests, and then the next time you want to run it, and you create your data inside the test cases. So you don't have to care about the volume to persist data, but I have one here. And then you do docker create with some parameters. The most important one probably this one, mcr.microsoft.com/msql/server and latest. And then you start your container. And what I then do is wait for a little while because I want the container to be fully started. When it is fully started, I download the AdventureWorks 2014 database from GitHub. Over here, I copy it with docker copy to my container. And then as a last thing, I restore it with restore DBA database, which is a PowerShell command from DBA tools. So I'm first going to destroy the container, destroy SQL instance. So now it's all gone. I don't have a container anymore. And do the setup. So setup SQL instance.ps1, that's the script you see on screen. So I now have the container. The loop is looking at the log to see that it's ready. Now it's ready. It is downloading AdventureWorks 2014 from the internet. It's completed. It's saving it, and now it's doing the restore of the database to my container, and now it's done. And if this is how long it takes to spin up a test environment for you, even with downloading a database and restoring it, why not use it? And then when you need another version, you just spin up a new container with that version. It's so simple. So, T-SQL-T. T-SQL-T is a unit testing framework for SQL Server. You can read a lot about it on tsqlt.org. But to install it, go to tsqlt.org, hit downloads, download tsqlt latest version. It'll give you a zip file which contains prepare server, which you will run first, and then you will run tsqlt.class.sql in the database where you want to do your unit testing. So I have done that. I have my AdventureWorks 2014 database. If we look into tables, we will see the normal AdventureWorks tables, and then we will see some T-SQL-T tables which live in the T-SQL-T schema. So these objects, you have stored procedures for the same purpose, T-SQL-T dot a lot of them. These ones, don't deploy them to your production environment. Exclude T-SQL-T from your deploys to production. But this is the test framework that I will show you a little bit about. So I'm in the AdventureWorks database, and I'm going to create a test that tests that if I run the stored procedure USP update employee hire info, that it actually updates the job title that I'm entering to the procedure. So first of all, I want to have a test class created. And the test class, that's nothing else than a schema inside your database. But this schema is also documented in the metadata tables that comes with the T-SQL-T framework, so that you can remove the test classes prior to production, putting it into production. So you can keep track of that. So don't put tests in the same schema as your user objects. Create a new test class with a new name, preferably containing the word test. So in this case, I'm going to create the class, which is a schema, test human resources. So we're running this first. Then I'm going to create a test procedure. So my test procedure lives in the schema test human resources. And I name it test that USP update employee hire info updates job title. You are probably not very used to object names with spaces in them. And me neither, and I don't like it. But this is the way to put a meaningful name to your test procedures, because this is a test case. You want to have a test report that gives a very meaningful information about what the test does. That's why the recommendation is to just put a bracket and then write a very descriptive name of the test, which will then contain spaces. Anyway, we will start with assembling information. We will then act, and then we will do the assertion. And assembling the information, what I want to do first is to just get an empty temp table with the job title column from the human resources.employee table. So simple insert into a temporary table with a contradictive where clause, where 1 equals 0. Then I make an insert into this table, and this is just because I want to have the correct column data type for it. So then I do insert into my temp table expected. I expect the job title CEO. So this is what I expect after the test has run. Then I do something which I think is pretty cool with t=t. I do execute the stored procedure t=t.fake table. Now what this procedure does is it takes the table that I enter in the parameters. So human resources.employee is the table. So it takes that table, removes all the constraints from it, gives it a temporary name, creates a new human resources.employee table without the constraints. And this is because I want to be able to insert test data into a table without having to worry about foreign keys and stuff like that. So it gives me the chance to just insert whatever information I want into human resources.employee. And the reason you want to do this is because the stored procedure USP update employee hire info, it will insert information into this table. And to be fair, it also inserts into pay history. So if I would have done this test properly, I should have faked also the pay history table. But this will work for now. It's just to show you the functionality of fake table. So then I do insert into human resources.employee. So now when I've done fake table, I now have an empty employee table, which is perfect for a test case. Because as I said before, you want to not rely on data that is in there. So we insert the data we need for the test case. So I insert one employee with a business entity ID 1, a national ID number, a login, and so on. And the job title, not CEO. So if we go up here, my expected outcome is that the job title should be CEO. So first I insert a employee with the job title that is not CEO. Then we execute the stored procedure with the parameter job titles equals CEO. So ideally, the procedure will update the job title to CEO. Then, when I'm done with that, I select the job title into the temp table actual from human resources employee, where business entity ID equals 1. That's the row with the test data that I inserted. And then I make my assertion. And with t=t, you can assert equals table. So it takes two tables as parameters. It looks to see that the tables have the same schema and the same content. So exec t=t assert equals table. Expected is my expected table, and actual is my actual table. So that's the test case, and then we can do t=t.run all, which will run all test cases in a database. There are some other run procedures. So t=t.run all, you can run a test class and you can run a specific test. But I'm going to do run all. So execute, all successful. So this means USB update employee hire info will update the job title if I enter a new job title. So a kind of simple test case, but still it shows how you can do the assertion. It shows you how you can fake a table. And now it is up to you to explore t=t. In the zip file from the download section, there is an example file which will give you, it will create an example database with some, I think it's it's supposed to mimic some particle acceleration thingy, physics that I don't understand, but I do understand the test cases in it. So that's a pretty good example of the different kinds of tests you can do and how you can mock tables and functions. So go on and explore T-SQL-T on your own. So that was T-SQL-T, a very simple example. I showed you how you can download it, where you can download it rather, and a simple first T-SQL-T test, including the fake table call to show you how you can mock tables and mock data. You can either do that, or you can use a completely empty database, and then in the test cases, you don't have to fake the tables. Instead, you can just insert the test data and then remove it afterwards. So it's up to you, whatever you like. I really like deploying an empty database, because then I know that I don't need to bother about the test data. And if you are using Docker containers for your dev environments, then you already know how simple and how lightweight a container is. And the cool thing is they're so easy to set up that you can, in your build pipeline, you will assemble the SQL scripts to build the database, and then you can deploy a Docker container and then deploy the database to SQL scripts, run them, and then you can run your tests in the pipeline. And then when that's done, you can just destroy the container and go on with life. So that's pretty cool. It's not T-SQL-T specific, of course, but it's nice to have for your unit tests. You don't need a lot of test data. You don't need a lot of infrastructure. You need just a simple, very lightweight container. It doesn't have to have almost any memory at all in it. Just run your tests and then destroy the container. Anyway, let's go on to the next demo, which will be the last section of this presentation. And it is the Visual Studio unit test project. So I'm going to show you how to set it up, how to create a unit test, and then how we will do our first change iteration. So enjoy the demo. So what I'm going to show you now is how to use SSDT database projects in Visual Studio, and how to create a test project, or how to use a test project inside Visual Studio. So to do that, I have created a little function in my SSDT database project. It is called isLeapYear. So isLeapYear is a function that, if you have taken a programming course, you probably have done one of these, but in another programming language. Leap year is the years where February has 29 days. So the years that are 366 days instead of 365. And the rules for them are, the first rule is that if the year is divisible by 4, it is a leap year. And then there are some exceptions to that rule. But this is the requirement that I got when I wrote the function. So I will start with that. This is the first iteration of my software development. So I have the function isLeapYear. It looks if in year modulo 4 equals 0. That means it's divisible by 4. Then I return 1, else I return 0. And I call the output column isLeapYear. So it's an inline table valued function with 1 column and 1 row. So that's the function. And then what I have done is I have right-clicked on it. I have chosen create unit tests, and clicking that will bring up a dialog for you where you can choose, do you want to create a new test project, or do you want to use an existing test project? I already did it, but the dialog is quite simple. My advice is to create just one test project per SSDT database project, because then you can use them together and test it. Don't create more than one test project for one single SSDT database project. But if we go down to Test Adventure Works 2014, which is the name of my test project, I have created one test class, which I call date validation. And if I double click on it, it will bring up this dialog for me. So this will show me which test cases have I created. So I have created the test cases, test is leap year positive 2004 and test leap year negative 2003. So let's look at the negative one first. I set up a variable, which will be my parameter to the function, with the value 2003. I run select star from dbo.isLeapYear, the name of the function, with 2003 as the parameter. And then I have set up a scalar value test condition. I've named it test 2003 is not leap year. It's of type scalar value. And then in the dialog over here, I have my condition is that column number 1 in result set number 1 should have the value 0. So I expect my function to return a 0 in its first column. If we look at the positive test, it's very much the same, except I expect the value 1 to be the outcome. So we can start with this and run through the test suite. What the test will do, because I have configured the test project to do so, is to deploy the database project to a target, then run the test cases. And I like to do that because then I don't need to remember to publish the project in SSDT. I can let the test suite publish it for me to my target. And speaking of targets, I would advise you to use a local target, preferably an empty database. It doesn't have to have test data because you create the test data in your test cases. In this year, I didn't need any test case data, but you should create it for yourself. So don't let the test project, when you run it locally, don't let it deploy to your shared dev box or test box, because then it will have data and that will interfere with the test. But it's up to you. If you deploy it to a target that already has data in it, you'll have to be very careful to set up your test data in a way that doesn't interfere with the existing data inside there. Because in the Visual Studio test projects, there is no fake table functionality. You'll have to write that up on your own, which really it isn't that hard to do, but you'll have to have something like fake table or something if you want to do it. Otherwise, you'll have to make sure that the test data does not collide with the existing data. And that's why I like to work with an empty database instead. Because we're not supposed to test other data. We're supposed to test functionality of our units of code, not the existing data. So let's introduce some new functionality, and let's do it in a test-driven methodology. As I said, a leap year is a year that is divisible by 4, but also with some other requirements. So one such exception is that if the year is divisible also by 100, it should not be a leap year, unless it's also divisible by, I think, 400, because then it is a leap year again. Because I know that year 2000 was a leap year, but the year 1900 should not be a leap year. So what we're going to do is create a negative test case. So let's add a test case. Let's name it test is leap year negative 1900. we declare in year as a small int, give it the value 1900, and then we do select star from dbo.is leap year within year as parameter. You could skip the variable declaration altogether. I just think it's a bit more clear to have that set up first and then the actual code run. As you can see here, when I create a new test case, there is already a test condition created for me, which is named inconclusive. And the type inconclusive means the test will fail. So it's a way to support the test-driven methodology to fail the tests before you even have the objects created. You don't even have to have the SQL code for the test case in here. You can create a test case with a name and make sure it always fails. I don't know if it's good or bad. I'd rather do the way I do it now. I write some SQL code that actually returns something, and then I make an assertion that will fail, and then I fix it in code. So let's remove this inconclusive condition and add a scalar value condition. So scalar value, hit the plus sign, give it a meaningful name, not the default, because that's scalar value condition 1. That will mean very little when you look in the test report, but instead test leap year negative 1900. Column number 1 from results at 1 should be 0, because I want the function to return false for the year 1900. One little caveat with the user interface, I hope they will fix it, is that the default for the property null expected is true, and if I enter a value into the expected value, null expected is still true until I move to the value column of it. Then it changes to false. So if you forget to do that, you will have the expected value 0, but also null expected, and you will have a failed test for a reason that will be hard to spot. So remember to change this. So now we set up the test. We can run the test suite and see what Test Explorer returns. Test Explorer is all red. So why is it all red? Well, because I created the test case for is leap year negative 1900, that it should be negative, but I didn't change the code of the function. So now I need to go in and write code to make sure the test doesn't fail anymore. So open the function and add case when in year modulo 4 equals 0 or in year modulo 100 is not 0. Save, rerun the test suite. Remember what I said, I have configured the test project to deploy to my target, so I don't need to deploy first. But this is interesting. Instead of getting more greens, I got more reds in my test results. So now all of a sudden, I'm testing that 2003 is not considered a leap year, and that test started failing. Well, it makes sense because I made a mistake. I put in an or where I should have put in an and in the condition. But the key thing here is that we spotted this now before I even deployed it to my shared dev box so that the other developers can laugh at me. Only I see this. I can fix the error, I can deploy, I can be sure that once my tests are all green, at least the things I test for actually works. So I fixed it, I rerun the tests, and hopefully we will see all greens. Yes, so now I know that at least the things I test for works in my function. So that's a very simplistic example of the test-driven methodology. Once you start to get procedures and function which are way more complex than this, you will see the benefit of having good test coverage before you go in and make changes, because you have automatic regression testing, as we saw in my little mistake that I made. So go and play with the SSDT database projects and the test projects. And if you like it, if you think it's workable, you will not think it's fantastic to begin with, but give it a couple of iterations, and I think you may start to like it. And it's very easy to put into your deployment pipelines in Azure DevOps, for example. You just include in the build phase, deploy to a Docker container, well, create a Docker container, deploy to it, run the test, destroy the container. It's very lightweight, so it won't make your pipelines go that much slower. So I do encourage you to at least play with it. If you don't like this tool, then look at T-SQL or some other tools, because I think introducing unit testing in your database will increase the quality of the code that you write and the systems you deliver. So in this demo, I showed you how to set up the test project, how to create your first unit test, and the first change iteration. Although a bit simplistic, at least I showed you the foundation of how it can work. So I hope, if you haven't done any unit testing before, I hope that you will start doing it, and I would be very happy to hear about your results and your experience with it. So hit me on Twitter or LinkedIn, and reach out and tell me how it goes if you start playing with unit testing. Thank you so much for letting me present, and thank you so much to the sponsors. Special thanks to Microsoft, and also a huge thanks to the other sponsors. Remember give the session feedback, give the conference feedback, and maybe most of all, visit the sponsors and exhibitors in the exhibitors hall. It wouldn't be possible to throw off a big event like this without having the sponsorship. So thank you to all the sponsors. Please go visit them. And that's all for me. Thank you.
Unleash the power of your data and drive innovation forward with uniquely simple, integrated solutions from Pure Storage that deliver a modern data experience.